Are we alone? Or, or do we live in a universe rich with other life? This looks like a question about out there, but it's also an existential question about us humans here and now. I, for one, would think of myself one way if I knew that we in our terrestrial biosphere were the only lonely living things in the universe. I would think of myself differently if I knew that the universe just teems with our cosmic cousins. Perhaps it's also a practical question, possibly even a predictive question. If life is common, that might mean that life is durable. And that's optimistic for us. But if life is rare, then maybe life is fragile. And that's a pretty pessimistic point of view. Challenging as this question is, it's worth working towards an answer. Frankly, we don't know what life anywhere else in the universe might look like. We don't know even if there is life anywhere else in the universe. The point is to follow the serious, thoughtful speculators who bring the best of the science they know to answer this question. So life needs planets. We live on planet Earth, and Earth is the only place in the universe for which we have actual evidence of life. More than that, when the serious speculators list the most general criteria for life, their lists require the kind of environment found only on a planet, or possibly a moon of a planet. Life that metabolizes, changes, and reproduces demands complex chemistry and a density of resources that simply are not present in the emptiness of space, the intense heat of a star, or the cold instability of asteroids and comets. We'll talk more about the details later, but a reasonable starting point is life needs planets. So if we want to know whether there is life beyond the Earth, planets are the place to look. The idea that the search for life in the universe is so closely connected to the search for planets has become exciting because of the discovery within just the last 2 decades of more than 5,000 exoplanets, planets that orbit in other solar systems around stars that are other than our sun. You can see a few of them in this gorgeous conception of exoplanets by the space artist Lynette Cook. In the center, you can see the Kepler Space Telescope, the mission that has discovered the lion's share of these worlds. Well, so far anyway. Other missions, TESS, and the recently launched James Webb Space Telescope follow hot on Kepler's heels. So let me quote the University of Arizona astronomer, Professor Chris Impey. Impey says, the recent explosion in the number of extrasolar planets or exoplanets is perhaps the most exciting phenomenon in all of science. Well, possibly you may think that astronomers are a little biased in making such a sweeping claim, but I in fact share this point of view, and I hope to convince you. So that we have a common starting point, let me tell you a little bit about the history of this question of life in the universe. The conviction that life might exist beyond Earth has centuries of history. It goes back far, far longer than our modern understanding either of life or even of planets. As far back as 1543, Nicholas Copernicus, this guy on the left here, declared Earth a planet, a body that orbited the sun. You see here the crucial diagram from the manuscript of his book, Revolutions of the Heavenly Spheres. Copernicus's idea drew attention, and we can go on and see this on the left here. The English astronomer, Thomas Digges, a little later, drew a very Copernican solar system. And by that, I mean you can see the sun there at the middle with the planets in orbit around the sun. And he put it at the center of an infinite universe of stars, which he also described as suns, just suns that were dimmer because they looked dimmer to us because of their very great distance. Just a few decades after that, the Dominican friar Giordano Bruno speculated that the universe contained an infinite number of stars orbited by an infinite number of planets, and that these planets were inhabited by intelligent life. Obviously, Bruno hadn't observed this. The idea probably springs from a philosophical belief that we can call the plenitude or the completeness of the universe, which is essentially, if it can exist, it will. Put in the terms that would have seemed most comfortable in Bruno's day, it's kind of theological. Surely God does not neglect to create any possible good thing. If that sounds a little metaphysical, consider how many of us subscribe to Murphy's Law. If it can go wrong, it will. Murphy's Law is kind of a modern evil twin of the idea of the plenitude. Now, Bruno's idea is also, though it's rooted in this very old and slightly funny conception, it's actually the Hermetic philosophy of the 16th century Renaissance. It also has a very, very direct modern appeal in science. It's related to a belief that still motivates cosmology, an idea that we can call Copernican, and that is our vantage point is not special. The universe, or at least the physical laws that govern the universe, should look the same everywhere. The Copernican idea is powerful and even necessary for us to do science at all, especially astronomical science, because if the laws of nature are different in other places, how could we possibly figure out what happens there with only our own laws to draw on? Well, okay, enough philosophy and back to history. Bruno, poor guy, was burned as a heretic. But this wasn't the end of ideas like this. A few years later came along Galileo, and you can think of him as a Copernican with a telescope. And he saw amazing new sights in the sky. Here, for instance, is his little picture of the Pleiades. And the Pleiades are 7 sisters. You may possibly know the traditional stars that have been seen in the sky are the big ones in this picture. And he saw all these other ones, the little tiny ones, which no one had ever before the telescope ever seen before. So Galileo saw these amazing sights and he wrote books publicizing them to every reader in Italy. In fact, really every reader in all of Europe. He did so with a whole lot of charisma and not very much tact. He profoundly offended the Pope and the religious authorities of his day. And you may know that Galileo was threatened with torture by the Inquisition. Nonetheless, in spite of this complicated beginning, the idea of the Earth as a planet and the universe as an infinite distribution of sun-like stars has seduced and convinced thinkers in the centuries since. Among them was this fellow, René Descartes. And if you've studied any philosophy, you know he's known to philosophers as the guy who claimed, "I think, therefore I am." He's known to mathematicians and scientists for Cartesian coordinates. Think graph paper, that you can graph a point with its x coordinate and its y coordinate. He's really known to historians of science for being someone with whom Isaac Newton disagreed on just about everything. But there's one thing that Descartes and Newton did agree on, and that's this idea that the stars are suns like ours, each the center of its own system, infinitely many of them stretching infinitely far away. Newton had overwhelmingly the better physics, the physics that has gone on to become the physics we use today. But Descartes had this very cool diagram of a slice of his infinite universe. And here you can see that every star is a center of its own system. You can find S in the middle as our sun. L and C and O are sun-like stars, and the whirly lines around them are the cosmic whirlpools that Descartes, I have to say wrongly, envisioned as carrying the planets around. And Newton has a more helpful idea on this. For Newton, instead of the planets being swept along in a whirlpool, they move by a combination of inertia and Newtonian gravity. But that aside, what we want for the moment is simply the idea that Descartes thought of similar whirlpools extending as the universe of sun-like stars and planetary systems off the page to infinity in every direction. So you've noticed a lot of people talking about infinity here. The first person to actually make a recognizably modern attempt, not simply to point about, to say that the universe goes on to infinity, but to actually measure the extent of our universe, well, that person was the multi-talented William Herschel. Herschel earned his living as a musician, which may sound a little odd. You know, your day job is earning your money as a musician, and at night you go out and do science for free. But nonetheless, that's what Herschel did. Music was not his real contribution. I mean, he is famous for building much bigger and much better telescopes than anyone before him, and by using them for projects beyond anyone's previous imagining. You can see the skeleton of his biggest telescope, a giant 40-footer, as photographed a generation later by William's son, John. Side comment, this is an iconic picture from the earliest years of photography, but we're lucky to have it because it gives us a sense really of how this enormous instrument might have looked. Well, back to William, he used these instruments with tremendous skill. He didn't just build them, he used them, and he used them with incredible energy and tenacity. He's famous as the discoverer of the planet Uranus. He discovered many comets and nebulae. Credit should probably also go to his sister Caroline Herschel, who participated in essentially all of William's doings and is individually responsible for discovering an awful lot of those comets. Surprised that she didn't get an awful lot of recognition in her day? Probably not surprised about that. Okay. Oh, and another thing Herschel is famous for is probably the first observations of infrared light. The most important thing Herschel did for our story, though, is his work on the construction of the heavens, 1785 here. And for this, he literally counted every star he could see in the Milky Way in his tremendously improved telescopes. I mean, going beyond the improvements of Galileo's tiny handheld ones to this 40-foot giant here. And Herschel counted them in an attempt to map the universe of stars. Well, Herschel's guess at size was a wild underestimate. Even his giant instruments couldn't begin to see to the edges of the Milky Way, and he misunderstood how unevenly stars are distributed, so he came up with this funny two-legged shape that you see here is figure 4. But its work was a truly admirable first attempt to actually measure the extent of what we would now call our galaxy, rather than to simply assume that stars stretched out evenly to infinity. Herschel also keenly observed the sun and sunspots. He convinced himself, cleverly but wrongly, that sunspots were windows through the superheated atmosphere of the sun to a protected interior surface cool enough to be habitable. Herschel was as much a planetudist as Giordano Bruno, and he leapt to the conclusion that the sun itself and every planet and moon in the solar system supported intelligent life, much like us, and he even wrote some charming little stories about what all these people did. Okay, well, so it's probably time for us to stop for a minute and reflect a little on some of the philosophy of the science we've gotten to at this point. And the first thing to talk about is scale. These scientists had a very limited understanding of the scale of the universe. While some of them, Bruno, Descartes, Newton, did think of stars as comparable to our sun, astronomers did not then imagine the solar system as one tiny element of a much larger structure, like our Milky Way galaxy, which itself is one of an uncounted number of comparable galaxies extending to unknown distances in a vast universe. Not at all. The unprecedented size and quality of Herschel's telescopes and his incredible energy and persistence, using them to make this exhaustive and exhausting census of visible stars, they made him the first to gain even an inkling of the scale of our galaxy. And it was a tremendous underestimate. So soon we're going to have to give some thought to the modern ideas of astronomical scale. All right, second, theory versus observation. Well, science is the interplay of theory and observation. You've heard this before, described as a scientific method. In astronomy, what this means is that telescopes and telescope-related technology are the important driver, the technology that expands the grasp of your observations. But observation is never the whole story. Science always seeks to understand process because process is science's approach to causality, to the why questions. Process thinking really is scientific thinking. Scientific thinking really is process thinking. But process, especially in something like astronomy, is more than you can see directly. I say especially in astronomy because astronomy is a matter of vast processes occurring over enormous time scales and enormous distance scales. So if science understands what it sees by means of process and by means of fitting observation into theory, theory being the framework that allows us to understand and to explain and to predict, then if we're going to claim to understand planets beyond the Earth, this is how we're going to have to do it. We're going to make theories about the process that governs their formation and their existence. And then we're going to have to test the predictions about the planetary parameters that our theories predict. And by that, what I mean is make theories about planets' motion and temperature and atmospheres and surface geology, and then go out and test those with observations, not just of our solar system, but of planets, exoplanets orbiting in other stars that are beyond, that are not our sun, that are way beyond our sun. So scale, theory, observation, process, prediction. The maturing of these ideas is the key to making science modern. And as we go forward, we're going to see how these ideas play out in the search for life and for exoplanets in recent modern astronomy.